So we're going to review factoring for the next couple days. And just humor me today, we are going to factor in a different way than we did last year. So if you like it, use it. If you don't like it, don't use it. But do you remember when we got to those problems with the leading coefficient that didn't divide out? Like 3x squared plus 7x plus 1? And remember that funny trick we did with the multiply and the factor, and it wasn't very fun? Well, I learned a way this summer to make that a lot easier. I do. And back when I was in high school, my way of factoring it was so awful. The way I taught you last year was a lot better, but I learned a new one this summer. So this first one, we just have a binomial. Whenever you have a binomial, you first want to look and see if there are any common factors. Is there anything that goes into 2x and into 6? 2. So if I pull out a 2, what's left? X plus 3. Does anybody not remember how that works? Everybody's good with that? You get it, Zach? You just making noises, or do you really understand? Okay. So on number 2, do 6x squared and negative 4x have anything in common? 2x. So if I pull out a 2x, what's left? 3x minus 2. Okay? That's not too bad, right? That's it. Look at number 3. What do 9x and 16 have in common? Nothing. If they have nothing in common, we call them? Yes, that's it. Okay. So last year, we factored this by saying x, x. What does this sign tell me? They're different. Two numbers that multiply to be negative 15 and add to be negative 2. 3 and negative 5. If you like that, use it. But for the rest of today, we're going to use a new method. And the new method will help us on those harder problems. It makes those harder problems so much easier. The new way is really easy. Okay? But I think so. It's harder to make a mistake in the new way. So, put your pencils down for a second. How come you're always so willing to do that? So, remember when I taught you how to multiply using the box? So I'm going to do that. X and negative 4. And x. Hang on, just hang on. I've reversed course for a second. So this would be x squared. This would be 8x. Negative 4x. Negative 32. So this is x squared plus 4x minus 32. What if I wanted to go backwards? So I'm going to pretend that none of this stuff exists. Okay? So let's start with the box. Well, the box contains diagonals, correct? So the diagonals are right here. What is in this very first diagonal? X squared. Now, what do we know about the second diagonal? It adds to 4x, and it has degree 1 less than x squared. So I know these boxes are x's. I don't know what the numbers are yet, but I do know that they add to be negative or positive 4. What's in the last diagonal? Negative 32. Well, are there numbers that multiply to be negative 32 and add to be 4? Well, it is, but you'll see it ends up being different later. So this is 8 and negative 4. Here's where it's different. Okay? What do these have in common? X. Well, if that's an x squared and this is an x, what goes here? Because this times this has to be x squared. So this is an x. Okay? Well, if that's 8x and this is x, what goes above the 8x? 8. Well, if this is negative 4x and the top is x, what goes on the left side? Negative 4. Okay? Now that looks really similar to what we just did in a different form, which is totally true. But when we get to the harder problem, it's going to make it a ton easier. Okay, that's a good question. So if I would have taken the 8 here and the negative 4 here, all that's going to do is change those. It won't matter. What it'll do is flip every diagonal upside down. But that's true. I mean, so the factors here are x plus 8 and x minus 4. And if I reverse these, that doesn't change anything. And even if it was a longer box, it would just flip every diagonal upside down, and it would take this side and swap it with that side. But that's a good point. Okay. So, please humor me for a little bit. Everybody use the box. If after today you don't like the box, throw it out. But for today, we're going to use it so that you can learn how to do those harder problems. And trust me, those harder problems are so much easier this way. I will never factor them the old way. And, oh, I forgot to tell you, you will need to understand the box to do division. When I learned division, we did something called long division of polynomials, which conceptually makes sense, but it's so easy to screw things up. And I'm not going to teach it at all. All I'm going to teach is division using the box, which is super easy. Yes. Its name is Frederick. Okay. So, take a look at number 5. So let's draw the box. What do I already know about the box? Okay. Are there two numbers that multiply to be 6 and add to be negative 5? Negative 2 and negative 3. Well, how do I know that that box isn't finished? Does my move to the right, move down thing work? I need the x's in there. So if that's x squared, this has to be x, and this has to be x. And that's a good thing about the box, is it reminds you to put those in there. Okay? Well, what does the top row share? An x. And once I know one term, I can figure out all of the others. What times x is x squared? What times x is negative 3x? Negative 3. What times x is negative 2x? And do negative 2 and negative 3 make 6? Yes. Everything today is a 2 by 2. Yes. No. So this is not the answer. The answer is x minus 3 and x minus 2. Well, the trouble is factoring cubic equations, x to the third equations, is really hard to do. They have to be, if they're a certain type, they're easy. But if they're just random, it's so difficult we don't do it. There are other ways to do it, and we use division. There's a way to look and say, well, I know the answer is 1, 2, or 7. And then you just try and see which answer is correct. And once you find one, then you break it down to a quadratic, because you only have 2 left. And then you do this. So there is a way to factor x to the thirds, but it's so messy nobody knows how to do it. We just ignore it. And really what we do is just graph it on our calculator and see where it hits. So, but that's kind of where we're heading, is finding the roots when there's more than 2. All right, what does number 6 say? X squared plus 14x plus 49. So I draw the box, x squared and 49. Are there 2 numbers that multiply to be 49 and add to be 7 or 14? 7x and 7x. So x here, 7 and 7. So what are my factors? And I'm just going to square it. Now, let me point something out that might confuse you. Okay? If we look at this row, what do they have in common? X. If we look at this row, what do they have in common? 7. And there's the x and there's the 7. If we look at the first column, what do they have in common? X. If I look here, what do they have in common? 7. Does that always work? Well, let's look at the one before. What do these have in common? X. What do those have in common? They actually have a -2 in common, but it's hard to see. How do I know that both of these have to be negative? Right. And a -5. So, when you're figuring out what goes on the sides, only factor out the top one and then use multiplication to find all the others. Because we pulled out this x just fine, and we used this x to build that and this and this. Okay? And the only time you're going to run into problems is when they're both negative. In any other situation, you can just find the common factors in the rows and the common factors in the columns. But if you have this situation, then you're going to end up with, well, what do these have in common? A 2. What do these have in common? A 3. But the negatives are missing. Okay, so don't do it that way. It doesn't work all the time. All right, number 7. So I draw the box. X squared and -56. What 2 numbers multiply to be -56 and add to be 15? 7 times 8 is 56. -7 and +8 multiplies to be 56, but what do you get when you add them? 1. So negative and negative will not make a -56. So 8 and -7, does that give me 56? But 8 minus 7 is 1. Does that work? No. What happens if I make that negative? Then this becomes positive. So these numbers don't work. Are there any others that do? No. Therefore, this is a prime cut of meat. Okay. Number 8. To the box. So we put in the x squared and we put in the 72. Are there 2 numbers that multiply to be 72 and add to be -18? -6 and -12. Now, if these are both negative, what does that tell me about my factors? These are both negative also. So what does the top row share? An x, and so this is x. That's -6 and -12. Now, once you get good at this, could you go straight from here to the answers? Yeah, you could. So x minus 6 and x minus 12. Okay? And again, keep humoring me. When we get to the harder problems, I think you'll like this a lot better. All right, not quite. We're not quite there. Number 9. What do you notice about 9? They're all even. We can pull out a 2. And if you use the box, you have to pull the 2 out, or it won't work. But you want to pull the 2 out, or it makes things harder. So I'm going to pull out a 2. What's left? You do understand, Zach. Okay, so I build the box. X squared and negative 7. Are there factors of negative 7 that add to be 6? So 7x and negative x. So my end answer is going to be x plus 7, because this is an x and that's a 7, and x minus 1. Is that it? I have to have the 2 in front. When can you just forget the 2? You can. When you're solving for roots. If all you care about is where the graph hits the x-axis, that 2 will change the graph, but it won't change the roots. So if you're factoring, you need to keep all factors. If you're finding roots, you can get rid of any multiple that you want, because all that does is change how the graph looks, but it will not change the roots. On these other problems down below. All right, number 10. Pull a 3 out. How do you know 84 is divisible by 3? You add 8 and 4 and you get 12, and 12 is divisible by 3, therefore 84 is divisible by 3. That's just how it works. If you take the number 1,251, so 1251, and you add those digits together, that's 9. Does 3 go into 9? Yes, so 3 goes into this. I don't know why. I sat down and tried to figure it out once, and I couldn't figure it out, so. Yep. So we pull out a 3, x squared minus 3x minus 28. Build the box. X squared and negative 28. Are there factors of negative 28 that add to be negative 3? Negative 7 and 4. So negative 7x and 4x. So this is an x and that's an x. This will be minus 7 and this will be plus 4. So my factors are 3, x minus 7, and x plus 4. Got that? Yes. The 3 must stay because we want factors. If we wanted roots, we could have forgotten the root. We could have forgotten the 3. Okay. Here's where the box shines. Can we pull out a 3? No. So, last year we did this funny multiplication, and then we rewrote the problem, and then we factored things out, and then we grouped, and it was awful. Which is way better than the way I learned it when I was in school. So let's just go ahead and make the box. 3x squared and negative 2. But that 3 and the 2 combine to make the middle term. Okay? So you're no longer just looking for the factors of negative 2. What we need to do is combine these 2 into one product. So what is 3x squared minus 2? Negative 6x squared. Are there factors of negative 6 that add to be negative 5? Negative 6 and 1. So negative 6x and positive x. Why not 2 and 3? One of them has to be negative, and you can't make a 5 with a 2 and a 3 if one of them's negative. Okay? So here's where the box shines. What do what do the two terms in the first row have in common? X. Well, if the left side is an x, what does the top have to be? 3x. Why? Because something times x is 3x squared, so this would be 3x. Well, if that is 3x, what's going to go here? -2. Because 3x and -2x make -6x. Well, if that's a -2 and this is a -2, what goes here? Well, nothing according to multiplication, which is a 1. Isn't that so much easier than what we did last year? Yeah. Well, forget what we did last year. You don't want to do it again. So my factors are 3x plus 1 and x minus 2. And I'm done. So if you want to use the old method to factor the easy problems, great. And then use the box for the harder problems, that's fine with me. Okay, one more. Number 12. Can I factor out the 4? Can I factor out anything? I can factor out an x. And in fact, I have to factor out an x. In order for the box to work, you have to factor out the x. Well, what happens is it ends up showing up twice in the box when it's not supposed to. But I don't want to show you how to do it wrong, so I'm not going to. So just remember, you have to factor it out or it won't work. Okay, so that leaves me with 4x squared plus 4x minus 3. Everybody's okay with that? I build the box. And I know we have 4x squared and I have -3. What's the trick we need to do? Multiply them together. -12x squared. Are there factors of -12? Oh, sorry. I'm going. You just times these two terms together. Okay? And the reason, so don't write this, but so if I had like x squared plus something x plus something, that is just the combinations right there. It's the combination of first and last and first. Yeah, it doesn't make sense. So the reason that we need to multiply these together is because that 4 is a combination of first and last and first. And if that doesn't make sense, forget I said anything. Okay, so are there factors of -12 that add to be 4? 6 and -2. So 6x and -2x. Now, in the top row, what do those two terms have in common? 2x. And once I figured out one of the numbers, I can figure out all the others. So if the left side is a 2x, then the top must be a 2x. And if the top is a 2x, then the bottom left would have to be a 3. And if the bottom left is a 3 and the bottom right is a -3, then the top right would have to be -1, and I'm done. So don't forget the x. Remember, we factored out an x in the beginning. X times 2x plus 3 times 2x minus 1. Okay? It actually makes a lot of sense that I'm not going into. So every time there's what is called a leading coefficient, there's a number in front of the largest exponent, you have to multiply first and last. Yeah, that's the only trick. Okay, so you got 5 minutes. Don't waste my time. Don't do the bottom section, but if you turn it over to the back, just do the top half. That's your assignment tonight. Finish the challenge and do the top half on the back. Yes, please do the boxes.